All right, today we're going to learn how to evaluate algebraic expressions. Apologize for my dress today. I came in, this is during break, so I know I'm not dressed very professionally, but it is break. Okay, so some vocabulary that we're going to be talking about today. A variable, most of you know what that is. It's represented by a letter in an expression that's math related. A constant, I'm not sure that all of you know what that means, but you'll know by the end of the time. Algebraic expression is what a math statement really is when it's got a variable in it, and how do we evaluate those. So that's what we'll be doing today. We're going to start out with an example. Some of you may know Harrison Ford as Indiana Jones, and I don't know that you knew that he was born in 1942. And you can find out what year Harrison turned 18 by adding the year he was born to his age. So if we added 18 to 1942, see if you can get that mentally, he would be, or what year would he be 18 in what year? Okay, so in algebra, letters are often used to represent numbers. You can use a letter such as A to represent Harrison Ford's age. So A, we're going to put in for his age. In this example, it's 18. And when he turns A years old, in this particular example, 18 years old goes in for that A. There will, the year will be, okay, let's see if you've got it yet. 1942 plus A. What will the year be? This year's constant. Okay, so you guys go ahead and tell me. Is it 1960? I think 18 plus 42 is 60, so it would be 1960. Okay, so now that you got that mental math out of the way, the letter A has a value that can change or vary. When a blank represents a number that can vary, and that's going to be a letter, it is called a variable because it's varying. It can be different numbers. He could be 18, he could be 23. We might want to know what year he turned 40 or 50 like me. Just yesterday I turned 50. So the year 1942 is constant. Okay, the year he was born is never changing. That's why it's called a constant, because that number can never change. So change goes in your second blank on the second slide. Okay, an algebraic expression consists of one or more, in this blank is variables. So we might have a different variable that we're adding into the mix as well, or subtracting into the mix, or multiplying or dividing. We'll see some examples of that in a minute. It usually contains constants and operations. For example, 1963 plus A is an algebraic expression for the year Mrs. Stevens turns a certain age. Okay, so this is a chart showing when I turned 16. So if you want to go ahead and try to fill in this chart, 16 plus, I was born in 1963, so what would that year be? What year did I turn 18? It's the year I graduated from high school. Actually, I turned 18 and then the new year came and I graduated the next year. But it's in that realm of of year, and I'll show you that in a minute. The year I turned 21 and the year I turned 50. Okay, and so down here at the bottom, we've got an algebraic expression where the constant is 1963, my date that I was born, or the year that I was born, not the date, but the year I was born, and then A represents my age, which is variable. It's changed throughout my life, and hopefully it'll keep changing. So anyway, on the first one, 16 plus 1963, hopefully for that one you got, oh, there it says, to evaluate an algebraic expression, substitute the number in for the variable, and that's what we're getting ready to do. Okay, so that was 1979. When I was 18, if I add that to the constant 1963, that's 1981. Now, I turned 18 in October of that year, so we have after the new year, that's 1982. So that's in the year 1981-82 is the year I graduated. Okay, then the year that I turned 21 was 1984. The year I turned 50 was this year, 2013, just yesterday. I turned 50. Okay, and so then there is our algebraic expression. Here's our constant. Here's our variable, the thing that's changing my age. All right, and here, if you'll write in that underneath these years, and if you want to, you could go ahead and draw, if you want to color code it with your correcting pen. The constant never changes, and so this is the constant in our algebraic expression. And the variable varies with my age. So the variable A, and here's some different varying ages that I've been throughout my life. We could do it for every age I've been. And we could keep on doing it until I die, which hopefully won't be a long time for now. Okay, so now we're going to do some checking for understanding. Let's see if you can do this. Let's see if you can substitute in a variable, a value for a variable, and add it. Here you're adding it to the constant 6, and you're evaluating to see what a plus 6 is when a is equal to 3. So you can turn off your the video right now and try those, and then turn back on and we'll go over it. Okay, well, welcome back. So in the first one, and here's another thing where you may not have showed your work, and I didn't want to show you how to do this beforehand because I want to make sure, and you can correct this if you didn't do it exactly right, but I would want you to go ahead and write down the original algebraic expression because we're going to evaluate it for two different numbers here. So write it down, and then we're going to take the 3 and we're going to substitute it in because we're saying a is equal to 3. And so that would be 3 plus 6. And then, of course, we know 3 plus 6, once we add it, is 9. And then for B, letter B, we're going to write a plus 6 down again. But this time, a is going to be 5. So when we do 5 plus 6, substitute that 5 in, we're going to add them together, 6 and 5, and we get 11. All right. We need to talk about ways that you can see multiplication division. We've talked about this before, but I just want to review it because there are different ways you may see multiplication and division represented in your algebraic expressions. So over here for multiplication, we've got 7 times x, and we could use an x. But the problem with that is, of course, you guys know, we might use x as a variable, so we don't really want to use that. So some other ways to do it, you could put the 7 next to the t. When you have a number next to a letter or a variable, it means multiply. You could do 7 dot t, so write that in, write these two in. And another way we could do it is we could put parentheses around it. We don't really need to, but you could. You could even put parentheses around both the letter and the number, and that wouldn't be considered incorrect. Okay, for division, q divided by 2. You guys know that the dividend always goes in the numerator on top, the divisor goes on the bottom. So you can put q over 2 like this, and sometimes we use a slash and say q divided by 2 that way. I like this way better than this because it's easier, especially when you get into algebra, which is what we're doing now, to see if I have to multiply this times, the number 2 or 1 over 2. You could just see it better because it's hard to tell what's in the denominator here. Okay, if you have all letters, all variables, same thing. You could put a next to b, and that means a times b. You could put a dot in between them for times. You could put a parentheses around one or both. Same thing over here. It's going to be s over q, which is the same thing as s divided by q. The s goes in the numerator. The divisor goes in the denominator, the r. Okay, when evaluating expressions, use order of operations. Okay, so now you're going to see some checking for understanding where you're going to plug in the numbers and you have to use order of operations. Okay, so if you look on your next slide on your paper, on your notes, these two checking for understanding, we have A and B. The first one says s divided by 5 plus s. So you're going to have to substitute the 15 in for both s's. B, you got 5x squared plus 3x, so you're going to put x is equal to 2, so you're going to put 2 in for x here, and you're going to put 2 in for x here. Be careful on order of operations. So go ahead and turn off the video and try those two on your own, then we'll come back and go over it. Okay, so for A, we've got s divided by 5 plus s. So we're going to put in 15 in both places where we have an s, and that's called substitution. So we've got 15 divided by 5 plus 15. Now what do we do first in order of operations? We multiply and divide before we add or subtract. So we're going to divide. 15 divided by 5 is 3. So we do that, and if you want to, I highly recommend, use your little lines there to know what you're doing first, and then bring down the plus 15, and then go ahead and do 3 plus 15 is 18. We're working down like a funnel again. Second one, we're going to substitute in 2 for x. Now, this says we're going to square the x, so you've got to have the 2 in parentheses when you substitute in the 2, because we're squaring the 2, and then we're going to multiply it by 5 by order of operations. And we also put a 2 in and multiply it times 3. There we need parentheses, so we know to multiply or a dot. So on that one, we're going to square first, because you always do exponents first. So 2 squared is 4, so all we've done is this part right here. And then now we've got multiplication and multiplication, additions last, so we can do 5 times 4 is 20, and 3 times 2 is 6. We can go ahead and do those at the same time, left to right, and then we're going to add, of course, and we get 26. Okay, last one, checking for understanding again. This time we've got 6 over a, which means 6 divided by a, plus 4b. So we have 2 variables this time for our checking for understanding. No different though, just plug in 3 for a and plug in 2 for b. Go ahead and do that one and turn off your video right now, and then you can turn it back on and check. Okay, so this last one, we're going to put in 2 for a, and we do that, we get 3 for a. 6 divided by 3 plus, now we're putting in b is 2, so 4 times 2, we need the parentheses there. Now we do division and multiplication left to right, and then we add last. So we're going to do 6 divided by 3 is 2, and 4 times 2 is 8, and then 2 plus 8 is 10. 10. So again, we're using our little funnel. All right, so you may review any of this again if you need to, but you should have all this filled out for tomorrow, and we'll see you then. Have a good evening.